Hello everyone, myself Dr. M. Pavan Kumar Reddy, Assistant Professor, Department of Mathematics, VNR VIGNANA JYOTHI Institute of Engineering and Technology. Today our topic triple integrals and evaluation of triple integrals. So last class we studied double integral and how to evaluation of double integrals. So triple integral is a generalization of a double integral. So double integral is evaluated over the region, whereas triple integral is evaluated over a volume bounded by a surface. Okay, example you can consider a sphere. Sphere surface is bounded, volume is bounded by the surface of sphere. So now here triple integral, which is generalization of double integral. Let us consider V is the volume. V is the volume bounded by a closed surface. Let us say S. Surface is denoted by S. Volume is denoted by V. So it is a three-dimensional space. So the coordinates are x, y, z. Let f of x, y, z be a continuous function which is defined over the volume V of rectangular coordinates x, y, and z. Okay. Suppose if this function f of x, y, z, which is defined over the volume V in a three-dimensional space, the triple integral of the function f of x comma y comma z over this region V is written as triple integral or the integral over V f of x, y, z dv. Integral over V f of x, y, z dv. Okay. So for the purpose of evaluation, we write this triple integral in the form, see here, integral x1 to x2, integral y1 to y2, integral z1 to z2, f of x, y, z dx, dy, dz. Here, these x1, x2, y1, y2, z1, z2 may be constants, may be functions of other variables. That means generally a z1, z are expressed in terms of xy, y expressed in terms of x, and x limits are constants. Of course, it is need not be like that only. You can have x in terms of yz, y in terms of z, and z limits may be constants also. Okay, but at least one of the variable limits must be constants. At least x, either x or y or z limits must be constants. Okay, so now let's discuss a problem on how to evaluating a triple integral. See, suppose if the limits are given, how to evaluate a triple integral, we'll see now. So evaluation of triple integral in Cartesian coordinates x, y, and z. See, evaluate integral 1 to e, integral 1 to log y, 1 to e to the power of x, log z, dz, dy, dx, dy. See here, first innermost, see this is called innermost integral, this is inner integral, and outer integral. See 1 to e power x, these are functions of x, whether these are y limits or z limits. See, these can be y or z limits, but in such case, if we are unable to know whether these are y limits or z limits, follow this order of integration. Okay, and see here, middle integral limits are 1 to log y. These are, of course, functions of y means these can be x limits or z limits. X limits or z limits. But also we have confusion. So we have to follow this order, x limits. And finally 1 to e, which are y limits. Okay, we follow this order and we evaluate first with respect to z, then with respect to x, and finally with respect to y. Now consider this integral. Integral 1 to e, integral 1 to log y, integral 1 to e to the power of x, it is log z, dz, dx, and dy. So first we have to evaluate with respect to z. So we treat x and y are constants. Of course, anyway, there is no contribution of x and y in the integrand. So it is y limits varies from 1 to e, and x limits varies from 1 to log y, and z limits varies from 1 to e to the power of x. It is log z, dz, dx, and dy. Now this is equals to integral y varies from 1 to e, integral x varies from 1 to log y. See, the integrand is log z integration with respect to z. So we use Eilert rule, that is ILATE which stands for inverse trigonometric, logarithmic function, algebraic, trigonometric, exponential function. Since logarithmic is a logarithmic function, log z is logarithmic function, so second one. And let us consider 1, which is an algebraic function. So use by parts formula to evaluate this integral. So by parts formula, let's take u is equals to log z and v is equals to 1. So what is by parts formula? Integral uv dx is equals to u integral v dx minus integral u dash integral v dx into dx. Okay. So now first log z, which is as it is, into integral v dx is 1 dz. So z it is minus integral u dash means log z derivative. It is 1 by z integral 1 dx 1 dz, which is z into dz. So upper limit is e to the power of x, lower limit is 1 with respect to x, next with respect to y, which is equals to now integral y varies from 1 to e, integral x varies from 1 to log y. Let's integrate. This is z log z minus, see this z and z gets cancelled, integral 1 dz is z, upper limit is e to the power of x and lower limit is 1 dx into dy. Let's substitute the limits. Integral y varies from 1 to e, integral x varies from 1 to log y, and now substitute instead of z e power x, so e power x, and log e power x, log e with base e is 1 now, so x minus z equals to e power x. Substitution of lower limit, which is 1, log 1 is 0, no contribution, minus 0 minus substitution of lower limit, minus into minus this plus z equals to 1 into dx dy. So this is equals to integral y varies from 1 to e, integral x varies from 1 to log y. It is x minus 1 into e to the power of x plus 1 dx dy. Now next integrating with respect to x. That is integral y varies from 1 to e. So now with respect to x, again we use the by parts formula. X minus 1 is algebraic function, e power x is the exponential function. Using highlight, this is u and this is v. So x minus 1 is as it is, e power x integral is e power x minus x minus 1 derivative is x minus 1, integral x minus 1 derivative is 1 into integral e power x is e power x into dx. Upper limit is log y and lower limit is 1 with respect to y last. So therefore integral y varies from 1 to e. Let's simplify this. It is x e power x minus e power x minus e power x integral is again e power x, okay, into log y 1 dy. That is equals to integral y varies from 1 to e. It is x e power x minus 2 e power x. Let's substitute the limits. Upper limit is log y, lower limit is 1 into dy. That is integral y varies from 1 to e. It is instead of x log y. So log y e power log with base e y. So it is y into log y minus 2 into e to the power of log y. It becomes 2y. Substitution of lower limit minus x equals to 1 e power 1. So it is e. Substitution of lower limit minus of this minus becomes plus 1. It is 2e into dy. So therefore it is equals to integral y varies from 1 to e. It is y log y minus 2y plus e into dy. Let's integrating this one with respect to y. Let's integrate this one with respect to y. So that is equals to, with respect to y, integration, y log y integration is y log y. See, already here we have done, no, y log y integration. So here log y is a logarithmic function, y is algebraic. So let's take this is u and this is v. So now first u is log y is as it is. Okay. Y integral is y square by 2. Okay. Minus log y derivative is 1 by y. Now y square by, see, first if you integrate once y, it is y square by 2. Again if you integrate, I am writing directly, it is y cube divided by 6. Okay. Minus 2y, y square 2 into y square by 2. Next plus ey. Upper limit is e, lower limit is 1. Lower limit is 1. Let's substitute these limits. Now this is equals to, see, instead of y, e. See, log e with base e, 1. So e square by 2. It is, so e square divided by 2. Minus, e, instead of y, e. This is 1y and 1y gets cancelled. So y square. So e square by 6. E square by 6. Next, here again, this 2 and 2 gets cancelled. Y equals to e square. So y equals to e. So it is minus e square. Okay. Next plus, instead of y, e. So it is plus e square. Substitution of lower limit. So minus 1. So log 1 0. No contribution of this term. Substitution of lower limit. So minus into this minus becomes plus. So instead of y, it is 1. So it is 1 by 6. Substitution of lower limit minus into this minus plus. Instead of y, 1. So it is plus. Substitution of lower limit minus, instead of e, instead of y, 1. So it is e. It is e. Let's simplify this one. See, plus e square and minus e square gets cancelled. So e square by 2 minus e square by 6. Let's take LCM. It is 6. 3e square minus e square. 2e square by 6. 2e square by 6 means e square divided by 3. Okay. Plus minus e plus 6 plus 1, 7. 7 by 6. 7 by 6. So this is the value of the integral. Okay. So this is, if the integral limits are given in Cartesian coordinates, we evaluate a triple integral like this. Okay. Next, we'll see one more evaluation of a triple integral if the coordinates are polar coordinates. Of course, in polar coordinates, we have here spherical, cylindrical. We'll go to the in details, those in the next subsequent classes. So now let's evaluate this integral. See here, we follow this order. So innermost integral limits are z limits, which are functions of r. Next, r limits are functions of theta, and theta limits are constants. Now let's evaluate this one. This is equals to, now theta limits are 0 to pi by 2 and r limits are 0 to a sin theta and z limits are 0 to a square minus r square divided by 2. It is r dz, dr and d theta. This is equals to. Now this theta varies from 0 to pi by 2 and r varies from 0 to a sin theta. So now first we are integrating with respect to z. We treat r as constant and integral 1 dz is z. Let's substitute the limits. What are the limits? A square minus r square divided by 2 and lower limit is 0. Dr d theta. Therefore it is equals to integral theta varies from 0 to pi by 2. Integral r varies from 0 to a sin theta. And r, let's substitute the limits. Instead of z, a square minus r square divided by 2. Lower limit has no contribution since it is 0. Dr into d theta. This is equals to integral theta varies from 0 to pi by 2. 0 to pi by 2. Now this 2 I am writing outside, 1 by 2. A square into r minus, it is, okay, integral r varies from 0 to a sin theta into, it is r into r square, it is r cube into dr d theta. Now further simplification. 1 by 2 integral theta varies from 0 to pi by 2. Integrating with respect to r, a square constant, r integral is r square by 2 minus r cube integral is r power 4 divided by 4. Upper limit is a sin theta and lower limit is 0 d theta. This is equals to 1 by 2. Integral theta varies from 0 to pi by 2. Let's simplify. Substitution of the limits, instead of r, a sin theta and lower limit is 0. It is a square into r equals to a sin theta. So a square sin square theta divided by 2 minus this is a power 4 sin power 4 theta divided by 4 minus substitution of lower limit. It is r equals 0, r equals 0. No contribution of the lower limits completely. So into d theta. This is equals to, it is 1 by 2. Here a square into a square, a power 4, here a power 4. Let's take this a power 4 common. Now integral theta varies from 0 to pi by 2. It is sin square theta by 2 minus sin power 4 theta by 4 into d theta. See here, we have a direct formula to evaluate this integral if the integral limits are in 0 to pi by 2. See, I'll write this formula here. Integral 0 to pi by 2 sin to the power of n theta d theta, which is equals to n minus 1 by n minus 3 by n minus 2, so on, 1 by 2 into pi by 2. This is if n is even. If n is even. And n minus 1 by n minus 3 by n minus 2, and so on, 2 by 3 if n is odd. This is the formula. Okay. Here, of course, in both these two cases, integrals, n is even number. So a power 4 by 2, it is 1 by 2 into sin square, n equals to 2, no? N minus 1 means 2 minus 1, 1 by n 2. Once you get 1 by 2, just multiply it with pi by 2, it is over. This is pi by 2. Minus sin power 4 theta, 1 by 4. Sin power 4, n equals to 4, n minus 1 by n minus 2 by n minus 2, n minus 3, where 4 minus 1, 3 by n minus 2, 2, 1 by 2 into pi by 2. Okay, this is equals to, it is a power 4 divided by 2, which is pi by 8 minus, this is 3 pi by 4 4 the 16 4 ja 64. Now it is a power 4 by 2, which is equals to a to the power of 4 divided by 2, and let's take pi common. Pi outside, 1 by 8 minus 3 by 64. 1 by 8 minus 3 by 64. Let's take LCM. It is pi a power 4 divided by 2. LCM is 64. 8 minus 3, which is equal to 8 minus 3, 5. So 5 pi a power 4 divided by 128. So this is evaluation of triple integral in polar coordinates. Okay. Next, suppose if the limits are not given, how to identify limits and evaluation of triple integral. We'll see one problem on this. See here, evaluate triple integral over V dx dy dz, where V is the finite region of space formed by the planes x equals 0, y equals 0, z equals 0, 2x plus 3y plus 4z equals to 12. Okay. Let's draw the figure. Okay. See, since it is a three-dimensional, see, we cannot draw on paper, just we have to consider like this. See, this is, let us assume that all these three are mutually perpendicular, x-axis, y-axis and z-axis. So like this, see here, say this is x-axis, say this is y-axis, say this is z-axis. Okay. Now x0, in case of two dimensions, xy plane, x equals 0 represent y-axis, y equals 0 represent x-axis. Okay. But in case of 3 dimensions, x is equals to 0 means yz plane, this quadrant. This is x yz plane, this is. In this plane, always x coordinate is 0. And y equals to 0 means xz plane, xz plane. And z equals 0 means xy plane. This is bottom. This is maybe if you are in a room, you can see the wall opposite to you. And this is the wall which is adjacent to you. Okay, you can imagine like that. And how to draw this one? See, if you remove this 4z, we can say it is 2x plus 3y equals 12 is a straight line. In case of 3 dimensions, 2x plus 3y plus 4z equals 12 is a plane. It's a plane. So suppose if you don't have 4z, so 2x plus 3y equals to 12. It's a line, straight line. We can identify the x coordinate and x-intercept and y-intercept, and we can draw the straight line. In the similar manner, you can identify here x-intercept, y-intercept and z-intercept by using this plane and plot them and join them by a straight lines. You get the plane equation. See, this is here V is bounded by x0, y0, z0. You simple remember that it is bounded by x0, y0, z0 means you are considering the region only in the first octant. First octant. In case of 3 dimensions, we say it is octant, not quadrant. So now first octant only. That means all x, y, z coordinates are positive. And the plane 2x plus 3y plus 4z is equals to 12. The line intercept form, like intercept form you write, divide this equation with 12. So x divided by 6 plus y divided by 4 plus z divided by 3 equals to 1. Now means this plane intersect x-axis at 6, that is 6, 0, 0. On x-axis, y coordinate, z coordinate both are 0. Y-axis, it intersect at 0, 4, 0. Okay, and z-axis, it intersect at 0, 0, 3. Join them by a straight lines. So this is the plane. See this triangular region, see here. This is the plane. Okay, this is the plane. This is the plane. 2x plus 3y plus 4z is equals to 12. Observe carefully here, integrand is 1. Integrand is nothing but you are finding the volume of this. This is also called a tetrahedron. Tetrahedron. This is a plane bounded by, see, plane bounded by, this is yz plane. This is actually x is equals to 0 plane. This is y equals 0 plane. This is z is equals to 0 plane. And this plane bounded by these straight lines, this is 2x plus 3y plus 4z is equals to 12. How to identify the limits here? See, here all the lower limits are fixed, x0, y0, z0. Remember, if all the coordinate planes is the bounded by the region is coordinate planes, all lower limits are zeros. Upper limits, so we express z in terms of xy, y in terms of x, and x limits are constants. How it is? We have to consider a prism. In case of 2 dimensions, we consider a strip in the region. No, in the similar manner, we have to consider a small elemental volume. We call it as prism. Okay, and onto the plane. This is, so this prism, okay, having its ends, lower end is on z equals to 0. Lower end is on z equals to 0. Okay, z varies from 0 to z equals to, upper end of the strip is moving on this plane. What is the plane equation? 2x plus 3y plus 4z equals 12. From this you write plane equation. In z in terms of xy, which is, it is 12 minus 2x minus 3y divided by 4. This is the plane equation z in terms of xy. So this prism, lower end is on z equals 0, upper end is on this plane, triangle, this triangle. Okay, so this is z limits. Similarly, y limits. Y limits means See here, we have to, so 3 dimension. 3 dimension to we have to come to 2 dimension. We have to consider the projection of this plane in xy plane. Let us consider the projection of this in xy plane. In xy plane, remember, always z coordinate is 0, no? If z coordinate is 0, then in xy plane, z, that is z equals to 0. In xy plane, the equation becomes 2x plus 3y equals to 12. Z equals 0, no? If you put z equals 0, we get 2x plus 3y equals to 12. So from this, you write y equals to, that is y is equals to, it is 1 by 3, 12 minus 2x. This is y. Therefore, y varies from 0 to 1 by 3, 12 minus 2x. This is. Now, in such case, it is, we consider a strip in the region. We consider a strip in the region, so that, see, lower end of the strip is moving on x-axis, y equals 0. Upper end is moving on this straight line. What is this straight line? It is 2x plus 3y equals to 12. Rewriting this one in this way, y equals to. So now to cover this region, this strip has to slide from the line y-axis. X is equals 0 to x is equals to 6. That means x is equals to 0 to, if you put y equals to 0 on x-axis, so it is 2x equals to 12. That means x equals to 6. 0 to 6. So like this, we identify the limits in case of 3 dimensions. Okay. Now this integral is equivalent to, therefore, it is triple integral over V. It is dx, dy, dz, which is equivalent to integral x varies from 0 to 6 and y varies from 0 to 1 by 3, 12 minus 2x, and integral z varies from 0 to 1 by 4, 12 minus 2x minus 3y. Okay. Integral, see, first with respect to z, then with respect to y, and finally with respect to x. See, innermost integral limits are functions of xy, so that's why we have to integrate first with respect to z. We treat both x and y are constants. Next we integrate with respect to y, we treat x as constant, and finally with respect to x. So here integrand is 1, so we are going to get the volume of this solid. Okay, so this is equals to, it is first integrating with respect to z, so x varies from 0 to 6, y varies from 0 to, it is 1 by 3, 12 minus 2x, integral 1 into dz, so z. What is upper limit? 1 by 4 into 12 minus 2x minus 3y, lower limit is 0. Next with respect to y, finally with respect to x. This is equals to integral x varies from 0 to 6 and y varies from 0 to 1 by 3 into 12 minus 2x. Integral z, instead of z, we have to substitute upper limit. See, upper limit is 1 by 4 into 12 minus 2x minus 3y. See here, lower limit is 0, no contribution at all. So into dy into dx. Next, integrating with respect to y. Integral x varies from 0 to 6. 1 by 4 is constant. Let's write outside. Integral. Now integrating with respect to y. So 12 is constant. Integral 1 dy is y minus 2 constant x. We are integrating with respect to y. We treat x as also constant. Integral 1 dy y. 3. Integral y dy. It is y square divided by 2. Upper limit is 1 by 3. 12 minus 2x. Lower limit is 0 into dx. So this is equals to 1 by 4. Integral x varies from 0 to 6. Now let's substitute instead of y. Instead of y, 1 by 3 minus 1 by 3 into 12 into 1 by 3 into 12 minus 2x minus 2x into 1 by 3 into 12 minus 2x minus 3 by 2 y square. Y square means 1 by 3 whole square 9. It is 12 minus 2x whole square. Lower limit has no contribution since 0, 0, 0. All becomes 0. Lower limit contribution is 0. So x. So it is 1 by 4. And this is integral x varies from 0 to 6. Let's simplify. This is 3 4 ja 12. So it is 4 12 ja 48 minus 4 2 ja 8x. Next minus, it is 2, 3 4s are 12. So 4 2s are 8. So minus 8x. Next, minus into this minus becomes plus. And 2 2s are 4. 4x square by 3. So 4 by 3 x square. Next minus, this is 3 3s are 9. Okay, 1 by 6 into, let's simplify this, 12 square. It is 144. 144 divided by 6. 144 divided by 6 is 24. Okay, it is minus 24. 12 square. Next, b square, that is 4x square. 4x square by 6. So 2 by 3 x square. So minus 2 by 3 x square. Okay, it is 4x square. So 2 2 ja 2 by 3 x square minus 2ab. Minus 2ab into minus becomes plus 2ab. 2 2 ja 4. 4 12 ja 48. 48 divided by 6. So 8. So 8x. 8x up into dx. 1 plus 8x and 1 minus 8x gets cancelled. And okay, well, let's simplifying this one. This is equals to 1 by 4. Integral x varies from 0 to 6. It is, first let's write the constant term, 48 minus 24, which is 24. Next, x terms, it is minus 8x. Next, square terms, 4 by 3 x square minus 2 by 3 x square. So, denominator same, subtract the numerator, 2 by 3. So, plus 2 by 3 x square into dx. So, now integrating with respect to x, let's see. 24 is constant, integral 1 dx x minus 8 into integral x dx is x square by 2 plus 2 by 3 x square integral is x cube divided by 3, upper limit 6, lower limit 0. This is equals to 1 by 4. Let's substitute. This is, instead of x, 6 it is. 24 6 it is 144. Minus, instead of x, 6. 6 square 36. So it is 2 4 36 4 it is again 144. Next plus 2 by 9. 2 by 9. 6 cube. 6 6 36. 36 6 it is 216. So it is 216. Again some cancellation happens. Anyway, lower limit has no contribution. 0 0 0. 0 0 0. So which is 1 by 4. Anyway, this is plus 144 minus 144 cancel. It is 3 3s are 9 and 3 7s are 3 2s are. It is again 3. So it is 3 24s are. So it is 48. It is 48. So the answer is 12. It's 12. So like this, if limits are not given, we identify the limits and we evaluate the integral. Generally what we do is we express z in terms of xy, y in terms of x and x in terms of constants, x constant limits. Okay, I hope you understand. So practice these problems. Okay. So if you have any doubts, contact me on this mail. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.